Hi, and welcome to today's webinar. My name is Alex Morris from the California Energy Storage Alliance, and I wanted to welcome you all here to our webinar today on maximizing decisions in wholesale bidding with AI-powered tools. You'll hear from me during today's webinar, but also I'll be joined by Wholesale and RWE, two important companies who are also CAISO members who are participating in the grid currently with energy storage, and you'll hear about some real-world stories. We're going to get started here. And so again, I'm the Executive Director with the California Energy Storage Alliance. It's my pleasure to welcome you today, and I wanted to run you through our agenda so we can get started. First, I'm going to have a couple announcements and introductions. Then I'm going to hand it over to Luke Whittaker from Wholesale, and he's going to talk about AI tools in the context of the CAISO's wholesale market, which is an area that CAISO focuses in significantly. Then we'll have Andrea Bianco from RWE join us, and he'll talk about real-world best practices for using technology-enabled bidding and how that's helped, including in some of the recent situations and extreme weather cases in Texas. So really interesting discussion today, and I'm glad you're here to join us. We'll have moderated discussion and also Q&A. So for any of you out there, we encourage you to type your questions in to the Q&A box on the GoToWebinar function on your computer. We do record these webinars for CAISO, and those are available on at storagealliance.org. And we currently keep all participants in listen-only mode. Again, towards the end, we should have ample time for Q&A, and we do hope to get questions from the audience. So I encourage you to participate as much as possible, and we'll field your questions at the right time. Thank you. Moving on, I wanted to share a little bit about CAISO. CAISO is the California Energy Storage Alliance, and we're the definitive voice for storage in California. We're about 100 members, and many of our members are some of the most serious and invested members in the energy storage sector in the world. California also is one of the largest storage markets in the world, and we expect that to continue and to grow. And so in joining CAISO, you're joining a 501c6 nonprofit whose goal is to be the voice of storage and a lot of policy and advocacy discussions here in California. I also wanted to share a bit about some additional, let me show our CAISO members, please. So again, really wanted to acknowledge and thank all of our CAISO members out there. If you're not a member, check it out. And I also wanted to look on the right side of the screen, we have some of our associate members who are the load serving entities. These are the ones who typically need to contract to understand storage, and it's a great opportunity to work with them as part of CAISO. Next slide. And so to get started, we wanted to make sure we knew who was in the audience and how we could help you. So please very easily click to signal to us sort of which camp you're in. And again, we'll be able to use that to inform how we structure our discussion today. And so you'll see the results pop up, and it's very easy to do. So we'll give you another 10 seconds to respond. Okay, so let's close the poll and we'll see what we got. Okay, so we have some developers, a larger percentage of technology providers, very few regulators, but we have some utilities and load serving entities on the call, and then some consultants. So for our panelists, let's keep this in mind, maybe a tech provider heavy audience, and then some developers and consultants and utilities or LSCs. So that's great. Thanks for everybody for participating in that. Now I wanted to jump into the webinar today. And again, this is supposed to be fun and informative. We're talking about some really interesting discussions. We're going to feature Luke Whittaker first. So let me introduce Luke. Later, we're going to have Andrea Bianco. But Luke, I wanted to just share a little bit about your story because Luke comes from Africa. He's currently the general manager of data science at Wholesale. And Luke, not to get too into your psychological profile, but it sounds like when you were young, living in Africa, you did have a 5-month citywide power outage. And it sort of strikes me that maybe that was important milestone in your life of highlighting how you really want reliable electric service, and here you are sort of creating that for people. So I think it's interesting. Just to give the audience a bit of background about you, yeah, you're working for Wärtsilä. You're doing a lot of important stuff there. You have a PhD in solar energy engineering from Penn State. You've worked with startups and whatnot, but I wanted to focus on your roles for Wärtsilä for a moment. You manage the R&D of their automated hybrid power plant dispatch system. So for the audience, so Luke's helped design systems to have microgrids and automated power plants sort of actively do what they need to do sort of through computer programming. And that works for island grids. And then also when you're participating in wholesale electric markets, he sets up the auto bidding services so that the resources know how to smartly be bidding and engaging in markets to make, optimize revenues, so to speak. So I know you also do power simulation efforts. So all of this is extremely relevant for today, and it's a great privilege to have you here, Luke. So thanks, and we'll advance the slides so that the audience can understand and get that content as well while you speak.
Yeah, thanks, Alex. I think thank you for a very great introduction. It's not me alone. We have a great team here at Wärtsilä. All of the things that I've been able to help steer and get into existence are large efforts of a team of people here. So I can't take credit for the success that we've had. I think it's really neat when you're part of a team building things that end up being critical towards all these functions. And yeah, thanks for just the bit of background from my childhood. I think, as a kid, when there's a 5-month power outage, at that time, I was not thinking about how to fix all the problems of the grid. At that time, I was simply learning about the little things that mattered to me, like having a DC solar lighting system in our house and things like that, right? So, I think there's, it was definitely foundational, but I think I had no idea where I would end up today at that point in time. So diving right in here, this slide is just a bit of a background on Wärtsilä. The poll was great. It's good to see a bunch of other technology providers. I know there's some of our competition out there listening in on this. So just be aware, as we field the questions here today, there will be certain things I won't be able to say because this is a public forum. But just at a high level, Wärtsilä provides technologies that are really focused on these hybridized power systems, whether you're a municipal utility trying to balance your exposure to the market forces or your own load profile, or if you are in a truly islanded scenario, or if you're just an IPP with power plants that you want to squeeze as much as possible out of. Wärtsilä has a lot of experience globally in this space, so not just CAISO, but today we're really going to try to talk mostly about CAISO. And you can see some of our customers along the bottom there as far as some key larger utility companies that we've been able to work closely with. So next slide. Okay, so today there's a couple things we really want to lay the foundation on, and then hopefully this will get some creative juices flowing so that we get some really good questions that we can discuss. I think today we're going to try to wrap up the slides within the first half hour here and leave a lot of time for Q&A. That's the structure. So one of the main areas where we have found our software solutions and the broader field of advanced optimization, AI, controls technologies. Again, I'm using buzzwords because that's really what is in people's heads. All you have so far is a title for this session. So we're going to try to put some boundaries around that so that we can have a more meaningful discussion. But so a lot of IPPs end up with a PPA of some kind, and some PPAs have specific call outs for energy storage. Some of them don't. Some of them just have some kind of financial structure that makes storage a good idea to go forward with. But at a high level, what what we see in the customers that we are engaged with, where our tools are being applied, or where you have some kind of wholesale market price exposure. So either you've signed a PPA to avoid some of that exposure, or you have renewable plants and you are exposed and you're trying to figure out, well, can I add some energy storage to be a hedge against that exposure? Ramp rate control is a big one, where you want to make sure that at your POI you're managing that volatility. We don't see that too much, I would say, in CAISO, but in other places around the world, particularly in any vertically integrated utility type of context. But in California, we definitely see the duck curve. So it's sort of like a broader grid ramping type of issue, you know, and that type of awareness informs that optimization. If you're aware that there's going to be a ramping issue later today that could cause price volatility or a more valuable time of day, then that's what feeds into that. Capturing otherwise clipped losses. So if it's a DC coupled system, or if it's an AC coupled system, but you have a shared transformer, so there's just a point of interconnection limitation there, and you want to be able to capture some renewables that would otherwise have to be curtailed. And then in terms of PPAs, you can have time-dependent pricing built into your PPA with some kind of arbitrage opportunity, or you could even have some kind of PPA with some kind of day-ahead scheduling requirement where you have to declare your availability or some kind of energy commitment in some form for that day ahead. And then finally, when you add a battery and you want to really optimize some renewable plant of some kind with that battery, the ability to provide ancillary services and dispatchability suddenly becomes something that you can do with that plant. And so you need to figure out how to optimize that operation, because if you're integrating with CAISO, you're going to get an external set point from them, right? And if you're participating in the regulation market, your AGC signal is coming in every 4 seconds, and you just have to do it. And so having a system that automatically is declaring, well, what's my availability, so that CAISO knows how to dispatch you within the boundaries that your system is capable of doing and that you want the system to be used at, is really important. So next slide. Okay, so just at a high level, AI is a buzzword that can be pretty frustrating because there's a lot of people out there talking about it. All the different battery vendors and technology providers all say all kinds of things about their AI capabilities, and I know that we at Wärtsilä are just as bad as the next guy in that regard. And so I think I just wanted to put some definitions up here to try to help set the tone for what we're really talking about here. So artificial intelligence, if you look up the definition, is any kind of computer software that's making a decision that otherwise a human would have been making, right? So this idea of like an if-else statement, if you look at the technical definition, is technically AI. You've enabled a computer to make a decision based on a bunch of conditions. And it gets more complex from there. And so this includes formal optimization routines, maximizing or minimizing something. And from there, that's really the foundation. That's been around since the 50s in terms of things we do with computers. But then within that, there's this smaller space of AI that's labeled machine learning. And so here you're taking an historic data set. A great example of a way we apply this and is commonly applied across the electricity sector is in a load forecasting service of some kind, where you have the historic load patterns, you have the historic weather data, and you can figure out, well, what are all the features that actually determine what my load is, and you can train a model to actually forecast that load and say, well, based on this time of the year, this time of the day, this weather data, I expect my load peak is going to be here. And so that's a very common way today where we use machine learning for a purpose. And the result of that is a new data, a forecasted data that can be used back in those algorithms again. And so you can pass that data that you've created with a machine learning algorithm back to the optimization routines and say, hey, based on the fact that my peak's going to be this high and at this time of the day, you can then optimize around that and get everything to fit in the most cost-effective manner. And that's what CAISO does with their dispatch, and that's what we do when we're optimizing a group of power plants, is we look at everything we're trying to optimize and get that to happen based on forecasts. And then the last one, deep learning. This is a little bit of it's more rare in the power system space in terms of something that really moves the needle, I would say, on these kinds of industrial utility scale systems. We don't have things like image recognition or chatbots, which you can see there. And I think there are aspects of deep learning that really do play a role, but it's a very niche area. And I would say that doing online training and automatic feedback loops is an area of AI where that machine learning level can be fully leveraged as well. So we're not creating a big Terminator robot that's going to take over the grid. In the end, here, the goal of applying AI is to enable people to have the visibility they need, to enable other automated systems to have the visibility that they need based on all the constraints in the system to achieve an end goal. So it's really about creating a deterministic approach where when you give it the same inputs, you're going to get the same outputs, and having decisions that are made based on that best knowledge that we have. So next slide. Okay, so as I mentioned, Wärtsilä has a pretty big global footprint. We've done a lot of work in ISOs around the world, but in the end, these wholesale markets have a lot of things in common, and then a few things that are different. And so, in the end, you've got these real-time markets that are clearing every few minutes. You've got several different rounds of bidding that occur ahead of time. You've got, in certain cases, week ahead or definitely day ahead bidding. And then in the context of CAISO, even in the real-time market, you have to get your bids in. It's a little bit more than an hour ahead of time for real-time bidding. And so these multiple rounds create this world where things get planned out, and then there's only a little bit of power that's being traded in that real-time market. And so most of those decisions have to get made pretty well in advance. And so those forecasts are pretty important for these kinds of systems. There's energy markets, then there's other types of ancillary service markets. And the differences all come down to things like settlement and what are the actual types of ancillary markets that are available, what are all the timings, are there any penalties for deviating from signals? And so all these things come together, in each of these different contexts a little bit differently. But in the end, a lot of them are really quite similar. And with CAISO, we've had systems in CAISO participating in the wholesale markets, including the ancillary service markets, for several years now, large-scale energy storage systems. And it's been really neat to be part of that transition for CAISO to get to a point where there are several big batteries operating today, ours and others, and the future is looking really good for CAISO. It's been a big lift for CAISO as a market operator to integrate these batteries into their economic dispatch engine, on the other side, because they receive bids and they have to clear them, and to actually get these batteries to be doing what they want in terms of filling in the gap and mitigating the ramps at the beginning and end of the day. So we can go to the next slide. Okay, so then I have a couple slides just looking at Aircot before I hand it over to Andrea to talk about some of the stuff from RWE's perspective. But so I just wanted to show, this is actually one of the sites in Texas that we have that performed really well during the recent outage that happened down there when it was super cold. And these screenshots are actually from before that event. But so the ancillary service market in Aircot that was designed for batteries, FRRS, was sort of designed as a bit of a pilot market. And the idea was that these batteries would send out a whole bunch of energy based on frequency very directly to help catch the grid before it drops even further in frequency, giving time for bigger engines to spin up and get that frequency recovered. And so you can see in the top chart here, it's a little bit small, but this system is tied very closely with some pretty large renewables. You can see the big wind turbine there in the picture. There's a big field of turbines right there at the substation where the energy storage is located. And that's pretty common for us to see that sharing of infrastructure, because in the end, the batteries are really supporting that existing grid. So we can go to the next slide. I'm going to zoom in on the top right chart on the next slide. And so you can see there's sort of the shape, and when the frequency dips, that's when that battery discharges a big amount of energy. And if we go to the next slide, we'll zoom in on the other chart that was on the bottom right. So you can see that during this time period, this is like, I think I picked a 4 or 5 hour window just to look at from the data inside of our platform that is visible to the operators of this site, that there's a massive wind loss event going on here over a couple of hours. The bottom right corner shows wind ramping down over a couple of hours, and that's the way renewables are. They come and go, you know, in a pretty volatile manner. And so as that wind is ramping out, it's a bit gusty, you know, every now and then it comes back and it keeps going down, and it's very difficult to have a wind forecast that actually captures some of that volatility in it. And so in real life, you see that what the battery is doing is filling in the gap. So there's a lot of big frequency response discharge events. So as that wind is ramping down, the grid frequency keeps having it keeps dropping off as other generation is coming online, and the battery is filling in the gap. You can see that the automated logic is doing a whole bunch of SOC steering. So you can see across, so positive on the top left chart in green is discharge and negative is charging. And so after each one of these frequency events where the battery has to discharge a whole bunch, because the state of charge in the lower left corner is a little bit low, during each one of these, the battery is working to recover that. So the automated control logic is configured and set up to be aware that these kinds of discharges are happening and see the state of charge go down, and to recover that state of charge as quickly as possible. And so there's this constant recharging happening between each of these events so that it's ready for the next one, because that wind is just really ramping down and getting out of the way. So this is sort of a view of just some production data that I think is really helpful to wrap your head around. Well, what's that actually look like? And this battery is pretty small compared to the wind. But it's following those signals and helping Aircot to provide the ancillary services that it needs to enable this high level of renewables. So next slide. Okay, so architecturally, I think it's helpful to just kind of label some things, okay? Our power plant controller is there in orange. Our cloud infrastructure is there on the right in orange, fleet director. And so this is what like a trading team or a battery operations team would be able to log into remotely, see all the production data. And in that cloud location is where any kind of bid generation or optimization function would live. And so whether people are setting configuration parameters and tuning things, or explicitly acting as a gateway for bid changes coming out of that system, or if they're just automatically flowing to a bid placement location, that's happening there on the left, whereas dispatch instructions and actual telemetry from the site is coming in and out of the power plant controller on the left directly. So it's easy for us to think of CAISO as this single monolithic thing, but from a technology perspective, they have a whole bunch of different systems inside that get hit from different endpoints, right? And so if you know, even the difference between the frequency regulation dispatch set points that change every 4 seconds, those come out of a different system than the 5-minute energy set points. And so this just kind of gives a bit of a view in terms of how all of this works. and third-party forecasts and integration can come in on the cloud as well there on the bottom. And so we've developed this platform over many years in collaboration with our customers and vendors and partners to really get a system that supports trading teams, because in the end, your trading team needs tools to do its job effectively, and that's really what we've you know, been working to enable. So next slide. So I think, you know, something that people think about AI is that it's going to replace people, and the reality is that that's not the goal. The goal is to augment people. You know, I think that can get a little scary if you think about it too much. But we're not talking about putting any chips in people's brains at this point. I think that the point we're really aiming for is giving people the visibility they need. If your trading team or operations team is used to operating conventional thermal plants or renewables, which are run of river, they just kind of go, and they maybe have some simple curtailment logic that CAISO or the grid operator can leverage. But with batteries, there's a lot more going on. Suddenly they'll do exactly what you tell them to do. They'll charge or discharge according to what you say, according to the bids you place, according to how CAISO clears them. And so having the right visibility into the long-term health of the battery, into the long-term you know, trajectory of energy throughput, into the whether you should be behaving more conservatively or less aggressively. Those are all decisions that humans need to still have visibility to make those decisions of risk. And so the right tools for these jobs really need to be put in their hands, and they need the visibility of the different data to be able to do that. I think that's it from my side.
Great, Luke. Thank you. Very interesting. And I'm excited to ask you some questions, but we're not going to do that just yet. What I'd like to do next is have Andrea Bianco join us. And let me just give a quick bio on Andrea. Andrea's from RWE, another PhD, you know, and has a lot of really relevant experience for this, having participated in the development or origination of both solar plus storage and wind plus storage projects. You also have projects that were actively operating in Texas, and RWE has, you know, quite a large fleet and is developing here in California as well. So again, Dr. Bianco, it's great to have you here, and thank you. And so we look forward to hearing your remarks as well.
Thank you very much, Alex, and it's really like a pleasure for me to be here. First of all, I live in California, I live in LA, but I think when we talk about energy storage and California, for people who follow soccer in Europe, is kind of playing the Champions League. So there are the best teams, the best players, is probably the toughest competition as well. However, at the same time, it's also very satisfying when you get one of the projects through the finish line and participating into the market. So yes, I'm going to describe a little bit what we do at RWE and basically how we see this opportunity from a developer and IPP perspective, bringing up also like a real case in where we use these tools and methodology, and also talking in general how this methodology can help organization to become more effective, to scale up faster, and also helping to transform ourselves as well. So starting from RWE, so I'm part of RWE Renewables. RWE Renewables is a company that was basically born by a larger transaction between E.ON and E.ON, RWE and Innogy. And RWE Renewables is the result of the merger effectively from E.ON Renewables and Innogy Renewables. We are active in the four renewables technology: onshore wind, offshore wind, utilities, solar, PV, and energy storage. We are also active in hydrogen. However, for just synergies with other business, the hydrogen business is under the generation part of our company, so it's not fully under renewables. We are active in basically the three continents, so in America, Europe, and Asia Pacific. We have a diversified portfolio, being wind and particularly offshore, one of our, let's say, best flag. So we are very active in offshore in Europe. We have a very large onshore fleet, and we are growing fast on solar energy storage, where probably the larger installations in the next year will come certainly from solar storage, particularly in the US. Also, as a geographical diversification, you can see basically 40% of our capacity addition has been in the US, while the rest, I think, mostly in Europe, with prevalence in the basically UK, in Ireland, and Germany. In terms of capacity addition for renewables, we have approximately 2.9 gigawatt of renewables currently in construction. We are running at the pace of 1.5 gigawatt a year, which correspond approximately to 1.5 billion investment a year. And for energy storage, we currently have a 600 megawatt battery storage project in execution worldwide. So in execution means that we have secured a final investment decision with our company. So we are quite excited to be part of the overall vision of the company, which is coming from a more traditional and conventional background, but now with the goal of transforming ourselves and becoming carbon neutral in 2040 through different steps. So we are really quite excited to contribute to this transformation. Next slide. Again, we mostly are active in the power generation, and of course with batteries we have different types of projects. So we have project in operation again in the US, and also project in operation in Europe, in a merchant market, or in vertically integrated utilities, or some hybrid of it. But in general, I mean, our interest is clearly on the revenue side, to try to maximize the revenues. At the same time, we are also market participants, so we want to be reliable, and at the same time we also want to ensure that the battery health is maintained. So again, the focus sometimes is very much into the revenues. However, our first responsibility as a power producer is clearly to have a reliable and safe operation of the battery, and at the same time also ensuring the integrity and the value of the asset for the long term. So in everything that you said before, then we clearly work together to really ensure that there is a very good trade-off, and actually that there are some points that from our point of view, they are not negotiable. So for instance, the state of charge management is clearly one of the things that we look more carefully, and we work with companies like Wholesale closely to determining what is the best strategy. And this is an example of a project with frequency regulation, in which we want to certainly ensure that the battery can respond to the signal, or following the frequency. That depends a little bit how the market is structured, if you receive a dispatching signal or if you are measuring the frequency locally. And you certainly have to, for the dynamics that Luke explained before, you have to control the state of charge when the frequency is basically constant at 60 hertz or at 50 hertz, depending on the continent. And then you try to recontrol the state of charge to basically go back to the initial point. And there are certainly some opportunities in extremely high volatile market, like for instance, Aircot is clearly one of those. And in situation like we experienced in a couple of summers ago, or to a certain extent also a month ago, in situation with extremely high prices, you also want to avoid to basically control the state of charge in the direction of charging when this situation of high prices occur. So certainly this is a good opportunity to use some of these prediction tools to make sure that you, just by knowing some information on the day ahead, and also knowing the forecast of your wind production, or how do you think the market is going to evolve, you try to control the state of charge mostly in the charging direction, in the time at which the power prices are generally low, or are generally low for that season. And we can see that in the top right plot. So try to bring the battery at the highest state of charge as possible before effectively the high power situation occur, and then basically let just the battery following the dispatch signal, but basically arrive to a low state of charge when basically it is a very strong power prices event have been expired. And then you clearly can build a model that learns from itself on the day-to-day basis. And of course, you try to maximize the revenues. Of course, you also want to ensure that the battery has enough state of charge to recontrol the frequency in both directions. And this is a practical example that we have already successfully implemented, for which we also always ensure that the battery was in operation, that the battery was always able to respond to the next signals. So again, it was one of the first, let's say, attempt that we've made in the direction, and in real life proven to be successful. In the next slide is just a placeholder to discuss also a little bit with you what is important, why it's important for a developer or also for a power producer, in particular also for an owner. So certainly the ability to have to make prediction is at the heart of clearly reducing the uncertainty. However, having these tools developed with the structure and also in the way in which Luke has described, give an enormous opportunity for a company like us, because effectively one of the first outcome of it is certainly the ability to be scalable. Certainly we are not going to eliminate all humans, but certainly it allows us to have an important factor in terms of scalability. So it allows us to grow quickly as business because we can rely on these tools. Certainly, I would say also one element that is also very important in the direction that, again, we are not going to replace entirely the humans, fortunately, is clearly also the regulation act to a certain extent to barriers. So the industry really needs to develop further to allow a full deployment of these tools, so to ensure that the process is fully automated. So in some markets, we still receive in our dispatch center phone calls when there is an outage from another power plant, if they ask us to modify our operational modes. So certainly the system cannot be automated if the regulation is not, let's say, automated as well. And if the industry does not make additional progress in change the policies in the direction in which also in terms of liabilities clear, if those tools are fully automated, then what happens in the scenario that have been not contemplated till now. So again, first, how we can capture the opportunity of this tool to scale. Big efforts needs to be made in policy development. And third point is certainly certainly the value of partnering with technology company, like for instance in this example for Varsilia. So when you build this project together, there is certainly the ability of sharing some information. So you clearly tend to learn a little bit from each other. But from our perspective, that does not have to act as a fear. So you clearly have to partner if you want to win. So we come from a company in which we have 1,600 people in the supply and trading organization of WE. So we think that we understand the power markets and the ancillary service market and the capacity market extremely well. However, partnering with a company of Varsilia that, in addition to the technology, they bring a certain different, say, more agile way of developing software, of implementing the platform, of course, some accumulated knowledge through also other projects that they have developed, created, let's say, I would say, an explosive partnership in terms of opportunities, so that we can quickly deploy new ideas without having sometimes also for a company like us to deal with the slowness and the bureaucracy of our organization. So probably a message for everybody: the partnership here is the key. Understand your strength, but also understand where your weaknesses are, and try to find the right partner to deploy this project. So this is overall what I wanted to share with you, and hopefully we will have some time to have some further discussion with your questions.
Andrea, thank you. That's excellent. And this is a massive facility site. Is that a real picture, or is that a mock-up that we were looking at?
That's a mock-up. Actually, it's one of the projects that we're in California, so it's supposed to show a little bit the landscape in California. So yeah, but hopefully it will be a reality in a couple of years.
Yeah, and I know I talk with our CAISO, and they're really hoping a lot more storage comes online to help in this summer, including, and so they would love to see that turn into a reality and see that many storage solutions showing up. So, hey, Luke, thanks for joining. And Andrea, thanks. That was excellent. We're getting a couple questions. So here's how I'd like to approach it. I'm going to field some of the questions, and to those of you in the audience, thank you for these. I see the questions coming in, and we'll weave those in. So Andrea, I'm going to start with you, and then we're going to talk about how Luke's service helps. So quick question about RWE. So how much renewable capacity have you guys built in the West, or roughly?
In the West, in the West of the US. I mean, mostly our fleet, I would say, in the US is of the probably 4 gigawatt that we are developing wind is mostly in Texas. So I would say probably 80% is in Texas. In the West, I think the solar asset that we developed originally were basically on a business model of build and sell. So, but I would say certainly on the 100 of megawatt. But certainly in terms of pipeline, it's actually one of the area where we have most of our, I would say, large projects. So, but again, the pipeline built until now was mostly focused in Texas and on the northeast side of the US.
Okay, and so this is where I'm going to get to Luke. So Luke, he's got a portfolio that covers multiple different organized markets and probably also non-organized markets like utility controlled balancing authorities. So let's say Andrea comes to you and says, hey, I need a partner who can help me smartly manage resources in all of these different areas with all these different market structures, with all these different prices and across the entire year. So how do you respond to that, and how does your service help them, just as a sort of basic, just connecting the dots for the audience?
Yeah, I mean, we respond great. That's what we've designed our software platform to do. I mean, I think in the end, an entity like RWE doesn't want to have to train their IT infrastructure team on multiple different tools. They don't want to train their trading team on the different ways to interact and view the data they need, and they need a place to log in to view everything holistically. And so, we comprehend the different nuances of each of those regions and get the integration to the actual ISO or dispatch authority figured out in collaboration with RWE's existing, team of people, and in terms of having the certifications or registrations to actually be a scheduling coordinator type of entity or whatever. RWE often has those in each of the different regions they're working in, and so we just navigate right through RWE. We don't go trying to pursue that ourselves, right? And so it's more about the technology and just making sure that the data flow and all the infrastructure and the cloud side is all there in a way that humans can consume it easily.
Okay.
And probably, Alex, if I can add, I would say that's why also we need a reliable partner, because we are ultimately the responsible QSC, and again, the responsibility and the liability in the market is on us. So for some of the work package is, for instance, with a company like Wärtsilä, so you clearly need a reliable partner, because again, reliability of the grid is clearly the first goal here.
Okay, and I think that, yeah, that's really important. Obviously, you can't. So a lot of the performance risk falls to you, Andrea, right? You're there, so you need a partner that's not going to set you up for failure. And then another question from the audience, just sort of again working our way into it, is, Andrea, you mentioned you have roughly RWE is 1,000 people who are working on these issues, probably very smart, very experienced, yet they still need tools. And so going to you, Luke, when you provide this type of tool, how much manual control does RWE still have if they want it? So that's a sort of question from the audience. And what percentage of the time can they opt in to just do it manually, or just hand over control to the AI that you've developed?
Yeah, great question. I would say if you have a reason to have that manual control, you have it. There's no issue. Anytime you need to do some manual control, you can. I think the issue is, if you're in CAISO, I mean, a great example would be with our different big batteries in CAISO, when they have to do, for example, a capacity test, normally somebody from our side, our operations team, who is saying, hey, we have to do the annual capacity test, when can we schedule it? So they'll get a meeting with not only our customer, but also there might be some third-party traders involved as well, who are part of that loop. and they'll figure out how to schedule that capacity test so that it's dispatched manually, but it's scheduled by phone. Some of the stuff Andrea is talking about in terms of like getting on the phone and getting that bid adjusted and making it clear that like, hey, we're going to do this discharge from this time of the day to that time of the day. It's going to be a full discharge. We will not follow any external signals coming from the ISO, but we will just do that. But you have to just get that scheduled on paper, and then you do it, and you're just a price taker at that point. So you just take whatever price there was in the market, but you can actually make money while doing your manual capacity test, no problem. You know, and I think that that's the beauty of the software, is that if there's a reason, there's always a button that says stop auto mode, and you can go do whatever you want. But I think then you're going to be exposed to those market prices, and it'll figure itself out in settlement later.
Okay, and then another question is about the tool's capability for managing state of charge, Luke. So let's say Andrea has 2 wind plus storage sites. The warranty on the first one is he wants to have slower cycling on the storage device, but on the other one he has a warranty where he can really cycle that. Can the software manage that type of different warranty and SOC control for different sites? And how do you deal with that in terms of setting that up for him?
Yeah, sure. So I'll take it first, and then Andrea, if you have some experience, you know, that you want to chime in with, absolutely. I think the answer is absolutely. Every site has its own warranty terms tied to it. And as much as possible, in collaboration with our customers, we try to give them as much flexibility as possible, because the reality of these markets is that, you know, if you have a warranty that say is, you know, 1 cycle per day, it better not actually be set up to be just 1 cycle per day. Hopefully it's like average throughout the whole year, and even average throughout the whole life of the battery. And hopefully it's flexible, that if you actually, you know, are regularly exceeding that, it just means your battery's not going to last the full, I don't know, 10, 15 years. It's going to be less now, right? I think the reality is that a bird in hand is better than 2 in the bush. If the market is there, drive that battery into the ground, make some good money. You know, I don't think you should be limiting yourself on throughput for warranty purposes if there really is a revenue opportunity that, you know, you're an early mover, you've got one of the first batteries in a specific location with high LMPs, like capture that. Who knows what other developer might put another big battery nearby to you and undercut that market. So you might want to drive your battery harder in the first couple years, and it's really up to humans to make those decisions. That's not something that like the AI is really capable of deciding that risk level today. You know, I think the reality is that we need to be giving power plant operators and trading teams the knobs that they can say, yeah, bid aggressively, operate with a battery throughput cost of 0, pretend that it doesn't matter how many cycles you incur, just maximize my revenue. But then if you feel like you're incurring too much cycles and there's no need to operate so aggressively, and you want to start saving the rest of your battery capacity, then you have that knob. You can dial it back and start participating less aggressively in some of those markets as time goes on. Andrea, any input?
Yeah, sure. I mean, I fully agree with what you say. I mean, first of all, the way in which we do it, then, Alex, practically is that. So yeah, I mean, clearly, Versilent would be true also with other, I mean, integrators. I mean, they clearly gave us access, right, to certain parameters, right. So for details, I mean, one of the important point of discussion when we work with a partner with that is like determine the DMP3 points that we exchange, right. So because we want to also make decisions on our battery, we want to exchange from our dispatch center information in real time. So that allows us to probably also do some analytics from our side and change also some settings from in real time, and then send it to the battery. So there is a mix of their intelligence and also our intelligence, and that allows us, for instance, to have 2 different strategies for 2 assets that are, let's say, very similarly located into the market. And on the warranty side, yes, I would say certainly, particularly for the merchant batteries, then if we have a 30 years PPA contract with a regulated utility, probably, yeah, we have to be very careful on the warranties. But in the merchant market, at least our experience is that in some hours you can make up, I mean, a significant portion of your CapEx, I'm saying in hours, right? So, and you really want to make sure that you show up and you get whatever you can get at whatever condition.
Okay. And then I have a question here that's sort of related. So Andrea's got his fleet out there. but a lot of the market information is public, Luke. So, you know, anyone can know what the ancillary services prices are, even though they're unpredictable. And so, you know, without sharing too much of your secret sauce, how are you guys better or tackling those uncertainties smartly or smarter than others in a way that's helping, Andrea?
So I would say that one of the core strengths of our software platform is simply the data visibility. And you know, Andrea alluded to it with his mention of, you know, a specific SCADA map of exchanging data between the GEMS system and the internal RWE systems, right? In the end, what GEMS is really doing is just being a data hub, just getting data from point A to point B in a modern, data efficient, bandwidth efficient, reliable, robust way, right? So that we can survive internet outages and not lose data. We can do all this kind of stuff. And I think that's really the core functionality that our software provides. In terms of data visibility, I think, or in terms of the fact that everybody can see the price data. So what exactly is our secret sauce? I mean, it varies, right? So I think in terms of, do we have a better price forecast than the next guy? I think in certain cases, maybe, but probably statistically, no. I mean, we have the same modern computing technologies, same machine learning as what everybody could apply. And I think we have a pretty good track record in terms of performance. We track performance of any of these kinds of forecasts or performance trackable decisions that we're making. And so we really give visibility to that. And our software platform is very third-party friendly. Like if RWE says, hey, we have identified this price forecast vendor as the best, and we've used them on other projects, and we need you to integrate this third-party price forecast on this project. Great, we're a data fusion hub. Like, let's set up that API, pull that data in, and boom, you have it, and it's visible not only for that site, but you can pull it up and view it inside of our fleet. So you know your operations center can see all of that easily too. So that's the key there.
And I think also, Alex, I mean, we're talking about in normal operation, but I mean, most of the time, I mean, when we really use the software, I mean, is when we have issues, right? So there are access to the data and being able to plot it in the right way. I don't want to spoil any of the GEMS functionality, but plot it and making comparison, understanding what started first. So the troubleshooting event, the troubleshooting ability to do it very quickly, right? Because I mean, we talk about this opportunity from the ancillary service market, but if you are clear for high prices and you don't show up, I mean, you can have thousands of dollars of damages, right? So in Aircot, there is this market called the supplemental ancillary service market. Again, if you don't show up, the penalty are severe. So the ability to quickly figure it out and then possibly also send people to the site. But I would say 80% of our event are solved just by dealing with the software and understand what happened and the resolution. So I think it's really the power of software, the data, and the ability to understand from the data what's happening.
Okay, so do you have an example? Is the recent cold storm a good example of where you use data like that, Andrea?
Yeah, we actually, I mean, we learned that other batteries were down, our batteries run well. So I don't have, let's say, a very specific example to talk about the specific battery, but I mean, in other, therefore we ran through, but we had some issues. For instance, we had a minor event, but I don't want to necessarily discuss it, and it lasted like for a few hours, not necessarily so related with the rest of the fleet. But for instance, in a very hot summer, we had a situation in which the substation was, we had some trip, and we also had to rely on the supplemental ancillary service market to buy out the capacity that we were clear on. And certainly, I mean, starting to understand what tripped first from the inverter, if it was a problem in the grounding in the substation, or if the things were coming from the DC side of the batteries. So the ability to quickly determine that, and also, of course, the support that you usually may receive also from them, because of course the software is from them, also the technology. Most of the time, when at least Versilia is selling the product, is a combination of hardware and software. But yes, I mean, in general, when it's an electrical problem related to an inverter, try to have a quickly resolution if it's coming from the DC side or the C side. It's extremely important because it also determines who has to go there and solve it, right? It's clearly our substation expert, or we have to figure it out with something that is more related with the battery system.
Okay. So go ahead. Yeah, Luke, go
I
ahead.
just
And
add
then
something
one more
briefly,
question.
which is that in addition to like hardware failures or things that really require like sequencing of events, often these AI, like any kind of optimization engine, is making a decision based on a lot of data coming in, right? And so the decision is a discharging set point or a charging set point or a bid, like what exactly bid should we do? How many megawatts in this market or that market? Why was there a bid change? Why did we adjust our bid? Previously, we were bidding in this market. Now we're bidding in this other market. And I think that in the same way that GEMS provides visibility in that hardware failure context, there's also an event log. There's a paper trail of all the different inputs that went into that optimization function. All of the different errors of the forecast that we're tracking, you can very quickly correlate in the GEMS platform. Well, the forecast error was very high in that market at that time. So we thought it was going to be lucrative, but then as time went on, we realized it was not actually there. So we shifted our capacity somewhere else. So you can you can quickly see those things with these tools.
So we're going to run out of time. I wanted to have one quick question though before you guys have a closing statement. So the question is, let's say RWE has a large portfolio of wind, but you start to add storage. And we know a lot of this is also happening with solar facilities. And so again, maybe starting with you, Andrea, and then going to Luke, what's the incremental complexity you face when you're adding storage? And then Luke, how are you guys tackling that and helping folks like RWE deal with that? Go ahead.
Yeah, I mean, certainly my colleagues from commercial analysis would be better able suited to answer this question, at least in terms of commercial exposure. But I would say from just a simple engineering perspective with some commercial knowledge, I can say that, I mean, for instance, for the event in Texas, we made a public release on some of the losses that the company had. On the other hand, since you say, Alex, the ancillary service prices are public, so somebody can go there and see basically how much the battery can effectively counter hedge some of the exposure that you have in the other technology, right? So for instance, you can also easily say, at least depending on the dynamic of the market, that in a situation in which there is no wind, in a market with a high wind penetration, it's very likely a situation in which the power prices are high. So if you have then the ability to dispatch the battery in this situation, of course you can hedge your exposure. I think at this point, the capacity installation of wind is so much higher than what we have in storage that of course you can just mitigate of a little bit. But I think when the penetration of storage will increase, I think we will also see this kind of portfolio effect being used really to have, instead of a financial hedge that you can get with any hedge of taker, you can start to build more like a physical hedge within your fleet, and certainly within the organization. Our commercial analysis team is actively looking at this opportunity, how to optimize the portfolio and not only the single asset.
Yeah, and you raise a good point. As the storage grows compared to how much wind you have, what I'm trying to get at is how much added complexity is there in a hybrid system in terms of the bidding there. And so Luke, maybe, because we're going to run out of time, so I wanted to give you the chance to answer. So looking at that type of complexity, let's say you had a 100 megawatt wind farm, you add 75 megawatts of storage, what sort of additional rigor goes into the dispatch and scheduling and optimizing that?
Yeah, I mean, adding the battery adds a lot more complexity. It's effectively a whole nother power plant. It's got its own whole way of working. Energy storage, it depends on your interconnection agreement. Some of these renewable plants that you can't actually charge from the grid with the battery during certain portions of the day, if at all. So I mean, there's a lot of complexity, because originally, especially if it's a legacy wind farm or legacy solar plant you already have your interconnection agreement, and you're trying to figure out, how do I add storage behind my POI, or how do I get a different interconnection application at the same substation that doesn't actually mess with my old interconnection agreement, but I can still do something commercially with these two things. So yeah, I would say each of our customers, we continue to see new stuff. Like this is not all solved yet. All of the different system operators around the country and around the world are still figuring out new rules, new ways to file for a registration of a hybrid power plant. Some of the stuff in CAISO just came online in the last year or so, of some of the first hybrid, true utility scale hybrid power plants of like a renewables plus storage. We're seeing that still for the first time. So we take our shared experience. The developer has a lot of experience on that side of things, and Wärtsilä has all of our experience in terms of actually hooking up all the telemetry and getting all the software data flowing. And together we're able to do these things successfully. You know, I think that that's been neat to just be a part of.
Okay, so you figure it out. Yeah. So we're just about out of time for the audience. I wanted to give a closing thought to each of you, and then I have a couple slides left just to wrap up. So, Andrea, if there's any sort of key takeaway you think the audience should know about optimizing bidding for hybrid systems, what is it? Go ahead.
Yeah, no, I think it's really like, I just want to say that it's going to be very exciting. I mean, there are so many things evolving into the market. How we are going to deal with the DC-DC coupling is a different resource ID. How we are going to deal, as you said, if you have in a same node, solar storage offshore and onshore, how we are going to optimize that. Can you kind of start to bundle this bidding? Can you bid, or how we are going to manage a physical hedge versus a financial hedge for solar and storage? So I think it's kind of very exciting coming to work every day. And also probably you made some assumption and then you were wrong, and the other times you were right, but things are evolving, right? So, and I think it's make it for our business, also because of this interconnection between the technology, the hardware and the software and the market. With battery, it's really connected, right? More than it can be with solar, and more certainly that it can be with wind. So I think the final remark is really that it's going to be excited how these things will evolve, and also give an opportunity for sophistication to win. And I think a company like WE like complexity, right? So because I think with complexity, it's where we think we can bring value, and we are looking for a complex world.
Good. Okay. Lots more complexity coming. Go ahead, Luke.
Yeah, I mean, I think software is one of those line items, you know, on any contract that's like, on one level, some people view it as a bit hard to swallow. Sometimes it's like, oh, that's like $1 million. Like, what's that for? If it's like a really big project. And other times it looks like a drop in the bucket because you actually realize what the software is doing and the value it's bringing, you know? So I think I think my final wrap up here is just that, like, none of our customers have all the answers, and we know that, and we also don't have all the answers. We know our technology, we've created our solutions to solve a very diverse set of issues that these systems face globally, and in the end, you know, we continue to have really good dynamic discussions, and people who are looking at getting into this space, you know, you really want to pick somebody who's not too green behind the ears, somebody who's been around for a couple years solving some of these problems. And there's only a handful of us who've been, you know, front runners, hooking up the first systems in CAISO, MISO, Aircot. That's us. So, you know, I think you really want to get a partner that solves those problems for you.
Okay. Great. And then, you know, for CAISO and Jake, we can bring up those slides just to wrap up. Gentlemen, thanks so much. From my side of it, I'm really happy to know there are smart people out making storage work, because I talk to a lot of California leaders and tell them how storage is going to be part of helping California achieve its renewable goals, how we should be one of the preferred types of new build and capacity in the system, not just in California where we're going to have thousands of megawatts of storage, but throughout the West. And so, you know, it's really important for me that the companies that are CAISO members take those reliability obligations seriously and show up prepared to really deliver and run an electric system, which I know we can do. On that note, you know, I just wanted to remind people, CAISO is here for you, and I hope you can join these types of fun networking discussions and getting market intelligence. We have a couple new offerings, including our market insight service for the Western states. So really understanding how storage markets are going to grow in that part of the US. And then also looking more specifically at storage in urban or dense load pockets, and that's the next slide on helping look at the LA area where they're really trying to wind down numerous older gas plants and really trying to understand specifically what's the recipe of storage you need in those areas and how will it have to operate to maintain reliability in these really massive, dense urban areas. So those are some of the thought leadership things we're focused on at CAISO. And I hope you can join us. If you're a member already, let us know. And if you're not, please be in touch. And I wanted to, again, step back and say thanks, Andrea, and thanks, Luke, from Wholesale, for a really fun webinar. It was great to have everyone here with us today. And with that, we appreciate it. Enjoy the rest of your week, and we will end our webinar. Thank you.